Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Alex who has completed the course Linux Basics for Robotics and he will be giving us a presentation on this. So what I'm going to do is to hand over the platform to him so he can begin his presentation. Alright Alex, whenever ready, let's go.
Hello, thanks for joining me. So before getting into the coding and into the Bash commands, I would like to give you like a brief introductions about the robot.
Mm-hmm,
So the fastbot robot has a LiDAR sensor. This is a rotating sensor that scans 30, 60 degrees around him.
mm-hmm,
So for this demo, it's used 5 specific directions, as you can see in the diagram. So 3 are frontal, front left, front right. Their main role is to detect whether there is an obstacle in the robot path. And basically, they produce the 8 cases that I will talk about later. The other 2 sensors, so left and right, they don't basically detect obstacles. They decide the turning directions when the frontal is blocked.
mm-hmm,
So the robot always turns towards to the side with more space. Um, so what you can see here, this is the core of the logic. So like I previously mentioned, the 3 frontal directions produce like all the possible situations.
mm-hmm.
So each direction has basically 2 possible states, blocked or free.
Yes.
So this means that 2 cubed gives me 8 distinct cases. So now the question is, how do I decide whether a direction is blocked or free? So what I did, I compared the measured distance against a safety threshold of 30 centimeters. So what is the distance measure that is below the threshold means the robot is blocked.
Mm-hmm,
Above, this means free. So if you look at the table on the right, each row shows a case and the action for it. For example, when everything is free, uh, like the last case, the robot moves forward. When everything is blocked, the robot checks the lateral and turns toward to the side with the more space. And yeah, this is basically how I translated the 8 cases into the code.
mm-hmm,
So everything becomes a if chain, and each branch check like three flags. So from left, front, and front right. And what actually happens? So the robot picks one branch per loop, perform the action, turn left, move forward, or turn right, and then the sensor starts over
mm-hmm.
for the next iteration, I would say. So this would be like the overview of the project.
Okay.
Now I can jump to the project itself. I will show. Okay. Can you see my screen?
Not yet. Okay, now we can see it. Yes.
Okay. So what I would do, I will connect to the robot.
All right.
Okay. Uh, I feel something is stuck.
Hmm. Um, can you try run till open the terminal and see if we can move it?
Yeah, actually nothing from, I mean, the entire browser is, because I cannot,
Oh, okay, it's doing like the last time. Okay,
mm,
maybe you can
yeah.
refresh it
I
one more.
remember if I stop sharing, I think it will work.
Okay, yeah, let's
Um,
try that.
uh, Now it's working.
Okay,
Um,
so you can share
I'll
again.
try to sharing again. No. Mm,
Are you sharing? Okay.
Wait.
Are you
I'm sharing
sharing?
the entire screen.
Okay, all right. Yeah, that's what I wanted to
I'll
say.
try.
Okay.
I'll try again. Okay.
I still can't
Um,
see your screen yet.
okay.
Did it accept sharing?
Uh,
Okay,
I mean, for me, I'm still sharing.
okay, now I can see it. Okay, and you can
Okay.
click. Okay, and I can see your cursor move. Okay, let's go for it.
Okay. So I will start the robot to move and see how the obstacle avoidance is working.
Mm-hmm.
Um, so for this, I would need first. So I will need two things basically. First, I would need to run wait. I would need to start this robot interface.
Mm-hmm.
So I need to go to CD. ah, This. Okay. And now in a different terminal, I would need actually to start the bash file for the obstacle avoidance. I would need to do the same thing.
Mm-hmm.
So see. It's obstacles. I guess you cannot see the robot. I will try to move the screen.
Mm-hmm.
Yeah.
Yep, I cannot see it yet.
I hope now you can see.
Can you try move the screen forward? So bring the camera stream window forward and your IDE backwards. So just click it.
Now you can see it.
Yeah, no, I mean the camera stream window. Yes, I can see it now.
Okay. Okay. So
It's
it
still
looks like there's a
hot.
small delay.
Yeah, yeah, it's a bit more delay, yeah. All right, yeah,
I
there
will
seems
try
to
to
be a
move
lot.
it a bit up
Yeah,
to see the some statistics.
there's a lot of delay between you saying something and then the screen showing what you're saying. But it's
Okay.
fine. So your camera stream is also glitching as much as I can see, or is it smooth on your end?
On my side, everything is okay.
Okay, all right. So it's somewhere between me seeing what your robot is doing and actually having it do exactly that. Okay, I see that. Hmm. All right, I can see it's moving. Okay, the weird thing is
You
that
can
I
also
can,
see the statistics.
yeah, the weird thing is that I can see your movements, right? So on your camera
Mm-hmm.
stream, but the robot movements are a lot slower. So I think something to do
Ah,
with
okay,
your browser sharing or yours.
probably.
Yeah. But anyway, let's see. Let's allow it to move a little bit more, and then
Sure.
we can go to the code afterward. All right. So we can. Was your statistic script running as well? So let's see that.
Um, I think I don't have it actually, but I made something, yeah, similar here. Not sure if you can see it, where is written the values from the sensors
I
and
see.
the value for each flag,
All right. All right. So you're
if it's
logging.
blocked or free.
You're getting that information. Okay. You needed
Yes,
you need that script to show like your automatic calculations, right? So to retrieve those values, but no worries. Okay, so let's stop execution here and then you can um, proceed
sure.
further with your presentation here.
Okay. Okay, so I should go through the code to explain it.
Yes, you have done that in part, so I was wondering if you wanted to continue with your slides. Did you finish? You were in the middle.
No, no, I finished the presentation.
Okay,
That was
all
all.
right. Yeah, that's good.
That's
So
a
let
lot of things to discuss, but I don't want to, yeah,
Yeah, you've
to
got all
have
the
the
time.
presentation for the entire.
Yeah, you've got all the time, but let's go to the code for now, right?
Yeah.
So, yeah, the general things that I'm going to ask you is regarding your thresholds, right? So if you set a threshold of 30 centimeters, right?
Mm-hmm.
In general terms, what does it mean for your robot? And can you tell me how you ensure that that threshold is enforced, right? So it doesn't go beyond that value. So basically, I'm asking you to explain in the direction of how do you determine the amount of movement your robot has to do, and how does
Mm-hmm.
that relate to your threshold values?
Okay. So maybe I can take as an example, um, so front left is not free. Maybe I will take as an example case three, when
Okay.
front left is not free and front is free and front right is not free. So
Yep.
basically the robot needs to go front. Yeah.
Mm-hmm.
So in order to do this, we need to check if we need to check these conditions. So wait, maybe it's better to start from, yeah. So basically, um, the, at this part, I get the real values from the sensors. So from the left, front, front right, and right,
Mm.
basically.
Mm-hmm.
Then how I define the the threshold. So basically here I do a comparison. So for example, if front left is less than the threshold, this means that I'm sorry. So this means that this front left is blocked. So basically the flag is blocked.
Mm-hmm.
So this means it has a value one. Then I do the same thing for the other flags. So the front blocked and front right blocked.
Mm-hmm.
So basically these are the, let's see, the important things for comparing the difference between the threshold and the actual value from the sensor.
Mm-hmm.
And
Okay.
once I have these flags, I'll return back to my example. You see, I'm comparing here the flags that I was checking previously.
Mm-hmm.
So for example, if front left is blocked, so
Yes.
one equal to one, and then front blocked, but it's not actually blocked, it is free, so it has value zero.
What do you mean by that?
Uh,
That's a bit contradictory, right? So you say when it's blocked, but it's
in
not
terms
actually
of,
blocked.
yeah, it's basically a naming convention that I used. That's the thing.
Okay, okay.
So
So
basically, is
let's try again, right? Because I want to understand that part because is per your implementation, right? So this is something that is
yes,
specific to how you implemented it, right? So it's important for you to help
yeah, yeah,
me understand what you meant.
sure, sure. So here is just a naming convention that I use. So these are some kind of flags.
Okay.
Front left blocked, front blocked, front right blocked.
Uh-huh.
So basically, these flags has either values zero or one
Okay, okay.
based on what's happening here, if it's true or false. Then I'm using these values here to do this comparison and define if I should either move forward or left or right. So this means that if this flag has the value one,
All right.
this means is blocked. If
Okay.
this value has value zero, this
Okay.
means is free.
Okay.
And if this one is has value one, this means is blocked.
Okay.
Maybe the naming convention is not really.
No, it's good. I
uh,
wanted you to talk
okay,
about it,
I
right?
see.
That's what I wanted you to do. So that's good.
Ah,
You've cleared it up.
okay. Yeah, so basically based on this expression here, it means that the robot is free to move forward in this
Okay.
case.
Mm-hmm.
So how do we know right now how much we need to move the robot? So with this implementation, the only thing we can mention to the robot is say how much the robot would need to move. But in terms of timing, I mean, we need to provide a time, like
Mm.
I will show you.
Mm-hmm. Mm-hmm.
So basically, we get the value from the front sensor. We make a difference between the front and the threshold, and then we make this division to 0, 1.
Y zero
This
one.
is basically this is basically the speed of the robot.
Okay. Okay.
So basically, this is a time formula. So in order to get a time, we have here the distance over the speed, and then you get
Mm-hmm. Mm-hmm.
the
And
time of the movement. Yeah.
all right. So okay, let's go on. I will ask you later what I wanted to ask you. Why did you choose to specify 01 as a literal, right? Why didn't you make it a parameter that you can use throughout the script, right? Because what if, here's a question, right?
Um,
You are setting, right? You're dividing by zero point 0.1 on line
mhm.
121, hoping that you will set your linear velocity to the same value in line 130, 130, right? 130.
Mm-hmm, mm-hmm,
What if,
mm-hmm.
right? What if you set that value to something else different, right? That means your calculation on the top was
I
not going to
see.
work. So you see why I'm asking, why did you have to
I
go
see.
the route of using literals when you could parameterize this so that you ensure you use the same value?
Yeah, it's true that it was better to use like some kind of global variable. So in case that at some point I would need to adjust the speed,
Mm-hmm, mm-hmm.
then it's easier to adjust from here instead of going into the code. It's true.
Yeah, good. So yeah, something you can
Um,
improve on. Yeah. Anyway, let's go on.
yeah, it's true. It's true. Um, okay. So then another thing was to subtract 1 second from the moving time. Basically, why this is done? Because basically the robot is not moving instantaneously, so
Mm-hmm,
it takes some time until the motor starts, and basically the robot will start moving. So it's basically some kind of, not sure if I can tell it a delay, but it's something to adjust a bit uh, the time of the robot.
okay, okay. So
Yeah, and here it's another thing. So at some point, when the robot run, it could be the option that the time that the robot needs to move would be negative. And if this happens, the robot will move, will stop, or probably will have some move behavior or something.
mm-hmm,
So in order to avoid this kind of thing, I'm checking here if the move time. So basically, what we calculated here is positive. It's a positive value.
mm-hmm. Can you tell me how that condition comes to be?
I mean, you mean why is necessary, or?
Yeah, so how does that okay, how do you end up with negative time, right? For you to have implemented a guard for it, you must have come across it, right? So how did that come to be? How did
Mhm.
you under what conditions would you
It
end
could
up with something
happen
like that?
because it could happen because, for example, if the front distance, for example, it's 0.38,
Mm-hmm,
it's true that it's greater than 0.3.
mm-hmm,
But when you do the subtraction between 0.38 and 0.3, this means you have 0.8 seconds to move, basically.
mm-hmm,
So if you reach this point and you subtract, if you do 0.8 minus 1, then
mm-hmm,
you'll have minus 0.2 in
mm-hmm.
terms of timing here. So
Right,
here
right.
that thing happens. So in order to avoid this, I put here a condition to check the moving time if it's positive.
Yes. Okay, okay. Makes sense.
So if it's positive, so if this flag, this is another flag move, okay.
Yes.
If this is positive, so more, yeah, it's okay. Then we set the speed to the robot, so 0, 1, and then we move. I added this sleep move time. It's basically the time that we calculated here,
Mm-hmm, mm-hmm,
the delay. So basically, we tell to the robot to move at that speed for this specific time.
mm-hmm,
And then when this is end, we set uh, the the linear speed at 0. So basically, the robot stops. Yeah.
mm-hmm, mm-hmm. All right.
If, for example, the value is negative,
Right.
this is the condition that. So here, basically, there could be also an improvement, but I did something like maybe, let's say, hard-coded. So basically, when this happens, the robot turns to the left.
Mm-hmm,
It's basically a saving option for the robot to do something, because when you turn to the left, you do an action,
mm-hmm.
and you have more chances to read like new values, and then to
Right.
do again the comparison, and the robot will move from that thing.
Right, right,
It could
correct.
be an improvement here. For example, maybe I can do a comparison between I lost maybe I can do a comparison between left and right, and
Right.
based on where there is more space, the robot can go into that direction.
Yeah, yeah, but this is good enough. I mean, for having a working script, this is good, and it
Yes,
shows
yes,
logically what you want your robot to do without a lot of confusion, right? So that's a lot more important to have
yes,
something simple and understandable. So yeah, well done on that bit.
yes.
All right, so unfortunately we are out of time, but very job well done, Alexandro. So
Thank you.
let's finish our conversation here. We're just going to wrap it up here, and then we will go speak on Zoom. All right.
Sure. Thank you.
All right, everyone. This was Alexandro's presentation, and a warm congratulations to him. I'd like to encourage all those of you who want to try this course. So, Linux Basics for Robotics, you can try it out for yourself, do the project, and then you get in touch with us so that we can have you also showcase your work and do the presentation. And at the end of the day, you will stand a chance to get your certificate. So, until next time, keep pushing your ROS learning. Bye bye.
See you.